Hello and welcome. In today's video, I'm going to give you a demo of how to create dynamic web pages on board the Calypso Wi-Fi module. Let us begin. The Calypso Wi-Fi module supports an onboard HTTP server which is used to serve the web pages on board the Calypso Wi-Fi module. This HTTP server supports a set of RESTful APIs which was primarily used to configure the Wi-Fi and network settings of the Calypso Wi-Fi module. With the introduction of the new firmware version 2.0, we have extended this set of RESTful APIs in order to perform additional functions such as control the remote GPIOs, configure the user settings, upload certificate files, and many more. The most important feature that is implemented with this new firmware version is the so-called custom API. Custom APIs are user customizable HTTP requests that can be used to create dynamic content on the web pages on board the Calypso Wi-Fi module. Let me explain how this works with the help of an example. Let us consider a typical IoT application setup where you have a sensor connected to a host microcontroller which in turn is connected to the Calypso Wi-Fi module. The intention is to read the sensor values and display it real time on a web page on board the Calypso Wi-Fi module. This can be achieved with the help of an HTTP custom request. All the user needs to define is a customizable keyword. This is, for example, in this case, temperature. Let us say we have a PC with a web browser, which in this case is the HTTP client, and it sends a HTTP GET request in the following format: custom/id equals temperature onto the Calypso Wi-Fi module. The Calypso Wi-Fi module recognizes this to be a custom API and forwards it to the host microcontroller. All the host microcontroller needs to do is consider this temperature keyword and perform a read on the temperature sensor and send the current temperature value as response over the AT command interface to the Calypso Wi-Fi module. The module will in turn send this to the HTTP client and the value will be displayed on the web page. Similarly, the custom API also supports a post request wherein it is possible to send commands like LED on and off via the custom API onto the Calypso module, which in turn will be forwarded to the host microcontroller to act upon. In this case, the host microcontroller can wait on this specific ID and perform actions like switching on or switching off the LED. For our demo today, we have the similar setup, but in the form of feather and feather wings. So the Adafruit M0 Feather Wing Express acts as a host microcontroller. We have the Calypso Wi-Fi Feather Wing with the Calypso module on board, and the sensor feather wing with 4 different sensors: temperature, pressure, acceleration, and humidity sensors from Würth Elektronik on board. As we know, typically with the feather ecosystem, it is possible to connect all these modules by stacking it on top of one another, creating a quick prototype in a couple of minutes. The firmware implemented in the host microcontroller on boot up connects the Calypso Wi-Fi module to the existing access point. I also connect my laptop to the same access point and send HTTP custom requests, for example for humidity, temperature, pressure, and so on, to the onboard HTTP server. This request will be forwarded via the UART to the host microcontroller. The firmware implemented on the host microcontroller reads the corresponding temperature, pressure, or humidity or acceleration value and forwards this via the AT command interface to the Calypso Feather Wing, which in turn forwards this to the HTTP client and the values will be displayed on the web page. Similarly, I have implemented the post requests to control the color of the NeoPixel LED present on board the Adafruit M0 Express. Let us begin the live demo now. As you can see, I have the three boards stacked up here, the bottom board being the Calypso Wi-Fi featherwing, the sensor featherwing, and the Adafruit M0 Express on top. I have booted up the module, and the whole system is now connected via Wi-Fi to my access point. It has the IP address 192.168.178.52, and I have opened the custom.html page on board the Calypso Wi-Fi module. Let me send a request to get the temperature value. As you can see, the temperature is about 23-24 degrees. Similarly, humidity, it's about 60% here. Acceleration, as you can see, the module is standing vertically upwards, so about 1G on the z-axis. And finally, pressure. So as you can see, using the custom APIs, it is possible to create a kind of interface between the client here and the host microcontroller, in this case the M0 Express. I've also implemented the custom post commands. Let us say we start by switching the NeoPixel LED to color red. I send the post command red, and as you can see, the LED is glowing red. Let's turn this to be green or blue, for example, or off. As you can see, it is really simple to implement such a web interface between the HTTP client and the host microcontroller using the new custom APIs of the Calypso Wi-Fi module. This brings me to the end of today's demo. Please do visit our product page on we-online.com for the Calypso Wi-Fi module, and the code that I have used for today's demo is also available on our GitHub page with the keyword Würth Elektronik on GitHub. Thank you for listening. Have a nice day.